In this question, there's a lot of text, of course, to read through. But here you'll see that Newton's law of cooling would state that temperature equals 70 plus 130 e to the k times t, and they tell us big T is temperature and little t is time. Then they give us some specific information. They tell us 30 minutes after the cake was removed. Well, this is a time, so they've just given us T equals 30. The temperature of the cake was measured to be 100, so that means our big T is equal to 100 degrees. What is the value of K in the equation? Well, we'll start with our equation. T equals 70 plus 130 e to the k times t. And now we can start putting some givens in. They told us T was temperature, and they gave us that as 100. And they also told us T, in this case, was 30. And so now the only thing that's left is this K, and that's what they asked us to solve for. What's the value of K? So I'll start by subtracting 70. And now we've got 30 equals 130 e to the 30 times k. Doesn't matter what order we put that in. I'll divide by 130. And so 3 over 13 equals e to the 30 times k. Well, since I have an exponential with e as the base, ln, natural log, will undo that. So if I have ln of 3 over 13 equals ln of e to the 30 times k, and now we can take advantage of our log rule that allows us to bring this exponent down in front, and we know that ln of e is just 1. So continuing on over here, we have ln of 3 over 13 equals 30 times k. I could turn this into a decimal if I wanted, but I'm just going to leave it because I know that I'm going to divide by 30. And now I'll find this value of k to several decimal places. So I wrote 5 decimal places down because they asked me to round to 4. So 1, 2, 3, here's the 4th decimal place. This 7 is 5 or above, so that means I'm going to write negative 0.0489. That 8 gets rounded up. So that's the answer to the first question. K equals negative 0.0489. So now they've asked, what is the temperature after 60 minutes? Well, that means they're looking for the temperature. That's the thing I don't know. I already know my K because I found it in the problem before, and I know that the time is 60 minutes, so I can replace those things. And this is an easy problem to solve because I can go right to my calculator and just plug in 70 plus e raised to that new power. And when I do, I get a temperature equal to 76.92 degrees Fahrenheit. Check yourself to make sure you can get that same value with your calculator. Now we'll look at part C. The only difference between B and C is they're telling us the temperature now is 80, and they want to know how long, so we're looking for the time. So time is now back in our equation, and the big T for temperature we know is 80. And my constant will be the same because this is still the same, what are we looking at? This is the same oven, same surrounding temperature, and the same cake. Everything is all the same. So I'll subtract 70, and we'll have 10 equals 130 e to the kt, and I'm just writing k because I'm too lazy to rewrite this in there. We'll divide by 130, The zeros will cancel. 1/13 equals e to the kt, where we know that k. Same as before, I will undo e with ln. So ln on this side, ln on this side. ln of 1/13 equals, I can bring this down as a multiplier, k which we know, t which we don't, times ln of e, but we know that's 1. So the last thing I'll do is divide by the k, and now I'll finally write it down. Negative 0.0489. After solving this, of course, we would do ln of 1/13 first, then we divide by that k. Time equals 52.48 minutes, which makes sense because at 60 minutes, the temperature was, whatever we had, but it was 60 degrees, if I recall, or 70 degrees. Anyway, answer to this is 52.48 minutes.